let's talk about the one place in the universe that doesn't care about your laws of physics, the black hole. First, quick reality check. Mathematically, literally anything can become a black hole if you squish it into a tiny enough space. You, me, your phone, everything in the universe has what's called a Schwarzschild radius. That's basically the minimum size it'd need to be crushed into so that its gravity is so strong even light can't dip out. Boom, black hole. For example, if you compress Mount Everest down to smaller than a nanometer, black hole. If you squeeze the whole Earth to peanut size, black hole. Thankfully, we can't actually compress things like that. But massive stars? Totally different story. When a huge star burns out and collapses, it crushes itself into a single point called a singularity, a spot with infinite density and gravity so strong nothing escapes. Okay, enough about how they're born. Let's fall into one. First, what would a black hole look like from the outside? Gravity bends space and time. We actually see stars behind the sun slightly shifted because the sun's gravity bends their light. Scale that up to something massive like a black hole, and the effect gets wild. Light from behind it gets twisted and smeared like a cosmic funhouse mirror. This is called gravitational lensing. The light curves around the black hole, creating a ring or smudge effect. Imagine a galaxy behind a black hole. As the light travels around it, it gets warped into weird shapes. If Earth orbited a black hole, it looked normal until it slipped behind. Then light bending would make it look stretched and distorted. Now, let's actually approach one. We're picking a simple black hole, no charge, not spinning, not eating up space junk, just chilling in the void. As we get closer, the sky starts warping. More and more of what we see turns into darkness. When half our view is blacked out, we've hit the photon sphere. Here, light doesn't escape, but it doesn't get sucked in either. It orbits. If you somehow paused here and looked sideways, you'd literally see the back of your own head, because light from behind you loops around and hits your face. And here's where time gets funky. Gravity doesn't just bend space, it bends time too. From an outside perspective, if someone's watching you fall in, they'd see you slow down more and more as you near the event horizon, the point of no return. Eventually, you'd appear frozen at the edge, your light stretching out until it fades into nothing. But for you, time feels normal. You just keep falling. For a supermassive black hole, you might not even feel anything at the event horizon. You're doomed, sure, but the ride would be surprisingly chill at first. But as you fall closer to the singularity, gravity gets way more intense. Your feet would feel a stronger pull than your head, and your whole body would stretch out like spaghetti. Scientists literally call this spaghettification. After that, it's lights out. Your atoms get torn apart. No one really knows what happens at the singularity. Maybe your matter gets erased. Maybe it pops out somewhere else. If the black hole spins, it might form a wormhole, a kind of shortcut through space. Not breaking physics, just bending it in a sneaky way. We can actually study black holes a bit here on Earth using something called a dumb hole, an acoustic black hole. Instead of trapping light, it traps sound. Scientists make them with fluids moving at the speed of sound. Not as dramatic, but they help us understand the real deal better. Another mind bender, what happens if you travel at light speed toward the sun? You wouldn't see it rush up. Weirdly, it looked like it's pulling away at first, because your field of view expands. You'd actually start seeing stuff from behind you. Light is catching up to you as you move at its speed. And where's the center of the universe? Trick question. It's everywhere. This idea is called the cosmological principle. Wherever you are, everything seems to be moving away from you. Think of it like dots on the surface of a balloon. As it inflates, every dot moves away from every other dot. There's no real center. If you pick any spot as your reference point, boom, you're the center of expansion. So when you look up at the sky, remember, scientifically, you are the center of the universe. One last brain glitch. If the universe were absurdly huge, like a Googleplex meters across, it'd be so massive that somewhere out there, statistically, there'd be another you, a cosmic twin living your same life. Wild, right? And as always, thanks for watching.
And also, this video was heavily inspired by the brilliant work of Vsauce.